All right, so for this game, looks like we have what is a pretty kind of standard in and out game. We basically have a bunch of these courses and they have to be taken in exactly one of these 2 semesters. So we'll set this up with the 2 semesters across the top. And we have the elements themselves. We have G, H, L, M, P, and R. And from there, yeah, I guess we can just take a look at the rules. So the first rule tells us that they have to take M and P in the same semester. So I guess M and P have to be together. Actually, at this point, it might be worth taking a look. Do we have any minimums or max? No, we don't. So there's nothing on spacing. So it's kind of nice that M and P are going to be together, but that's only going to go so far if we don't have any spacing restrictions. Anyways, next. It is not the case that they take both physics and religion in semester 2. Now this one, there's a couple of ways that you could arguably symbolize this. I guess the simplest, most direct approach would be to say something like P and R are not both going to go into number 2, which effectively means that at least one of them is going to have to be pushed into number 1. Now, you could have also done this as a conditional statement for the record, because this is basically kind of a standard. If one of them is in 2, then the other one gets pushed into 1. And that might be useful if you notice that some of the other rules are going to interconnect with this. If not, though, then this is probably straightforward enough. The idea that they just cannot both go into 2 together. Next, if the students take history in 2, then they'll take G and L in 1. Ooh, okay, so if they have H2, then they'll have to have G1 and they'll have to have L1. So contraposed, I guess we can say that if we have either one of those guys in 2, then we'll have to have H in 1. So that's pretty good. We can create another placeholder. We can say that, for example, between H and G, they can't both go into 2, so at least one of H or G will have to go into 1. So 1 is getting kind of tight, which is nice. Lastly, if they take M and G in 1, then they'll have to take L in 2. So this one we're going to have to kind of keep compounded because it's an and statement in the sufficient. So if we can say something like, if we have an M and a G both in 2, then, oh, whoops, no, that's incorrect. If we have M and G both in 1, then we'll have to have L in 2. So contraposed, if we have L in 1, then we'll have to have either M in 2 or G in 2. For the record, though, this sort of rule, when it says something like, if 2 elements are on one side, then the other element has to go on the other side, a simple common sense way to kind of understand this restriction is to really just say that between M, G, and L, they can't all go into 1, or in other words, at least one of these guys, M, G, or L, will have to go into 2. Now, a 3-person placeholder isn't probably not going to be the most influential kind of thing, but it's kind of nice because this right here is pretty much the entirety of the implication of this rule. That last rule, the only real thing it kind of commits you to is to saying that the 3 of these guys, they just can't all be in 1, so at least one of them gets pushed into 2. Now, is there anything else that we can do with this? And it doesn't seem like much. I mean, M and P, wherever they go, they're going to take up 2 spaces, and that's kind of nice. And we have kind of this, I guess, the second semester is kind of limited. If certain people go there, it kicks other people into 1, but still, it's kind of open. I'm not sure there is much that's worth looking into. You know what? Let's just run into the questions. So the questions themselves. Number 6, which of the following could be a complete setup of the game? So as usual, our standard exclusion question. First rule: M and P are supposed to be together. So going through the answer choices, A looks good, B looks good, C's good, D is good, and E is not. We can get rid of answer choice E. Next, P and R can't both go into 2. So A looks, oh no, A does not work, so P and R are both in 2. That's not going to fly. Answer choice B has them not both in 2, as does C, and D is okay too. Next. If they take H2, then they have to have G, L, and 1. So answer choice B has H2 and GL and 1. That's fine. Answer choice C has H2 and we don't have GL and 1, so we can get rid of C. And D has H2 and GL and 1. We're good. Next. Lastly, if we have M1, G1, we'll have to have L2. So we're just down to B and D. Answer choice B. So we don't have the rule. We don't have M and G on 1, so that's fine. And D, there we go. We have M and G on 1, but we also have L. And as we said, this rule just comes down to saying that you can't have all of them on 1. So that gets rid of D. And the best answer here is answer choice B for question number 6. And as usual, I suppose, let's just kind of plug that in. Answer choice B has G, L, R, H, and P. Onwards. So the first local question that we have here looks like question number 8. So to take geology in semester number 2, well, let's see what that does for us. If we have G in 2, what does that mean? I mean, that kind of takes care of this rule, right? But it doesn't do anything further because arguably they could all go into 2, so there's no real... Oh, but wait a minute. Yeah, we can use this. If G is in 2, then we have to force H into 1. Can we do anything else? I suppose, I mean, we know that 1 of P or R will still have to go into 1, but that's not that useful. Really, these last 2 rules don't do anything for us right now, so really it's just these 2 in play, and just M and P have to be together, so I'm not sure what more we can do. Let's take a look. The question itself asks, which of the following, each could be true, rather, except. So we're looking for the one answer choice that cannot be true. Answer choice A, they take exactly 2 courses in 1. And maybe, I mean, we have to have at least 2. Could we have just 2? Maybe. Let's keep that open. Maybe there's something else that might go wrong there. Answer choice B, they take 4 courses in 1. Ooh, can we have 4 in 1? And again, maybe there's no real further commitments on 2. Answer choice C, they take history in 2. Oh, that's not going to fly. There we go. Best answer to question number 8 is C. Onwards. Question number 9 is global. Let's come back to it. Number 10. If the student takes physics and religion in the same semester, so if P and R are together, actually wait, no, if they're together, they're going to have to go together in 1 because they cannot go in 2 together. So that's a good start. And then from there, can we do anything else? Oh, well, M has to join them, right? Because M's always with P. And I suppose we can still bring down the placeholder because as far as these guys are concerned, for example, H and G, we still have to have 1 of them over here. And that brings us up to 4, so that's pretty good. And I guess the only rule that remains is we have to have 1 of M, G, or L at the very least in 2. But I guess I'm not sure we can do much more. Let's take a look. The question itself asks, which of the following could they take in 2? G in 2? Well, could they take G? Well, actually, let's simplify this. We know that all of these people, P, R, M, cannot go into 2, right? So that would get rid of, ooh, that's nice, C, D, and E. And I guess that leaves us with A and B. Now, between A and B, G and H, one of them can't go into 2. Is it H? Well, I mean, H has more of a restriction, right? Because if we trigger H2, then we'll have to have, oh yeah, there we go. You'll notice that if we trigger H2, you'll have to push G and L both into 1, but that would mean that all 3 of these, because M's already here, right? So you'll have to have M, G, and L in 2, and that's not cool. So I guess H cannot go into 2. That knocks off 1 more. The best answer becomes answer choice A for question number 10. Next, number 11. If they take literature in 1, well, once again, what does that tell us? Well, if L goes into 1, I mean, this rule is useless, of course, right? Because that's a dead end. But this guy, I guess, we still have to have 1 of M or G on 2. So I suppose that's something. I'm not sure what more we can do, though. This feels pretty much kind of a dead end. I guess we can say that 1, we can bring down placeholders. 1 of P or R is still on 1. That's something, but Yeah, I don't know. Let's take a look. The question asks, what now must happen? Answer choice A, they take history in 2, and I don't know that. Answer choice B, they take math in 2. I don't know that. Actually, I shouldn't cross these off. I didn't quite prove them wrong. But answer choice C, they take religion in 1. Again, I don't see why. Answer choice D, they take at least 3 courses in 1. We'll have to have at least 2. Do I have to have a third one? I'm not sure that I do. Let's hold off on that for a second. They take at most 3 courses in 1. Oh, do they have to take at most 3 courses in 1? That seems less plausible. Because couldn't they take more? Sorry, couldn't they take more? Because 2 barely has to have anything. We barely have any commitment. So let's take a look at answer choice D. They take at least 3 courses in 1. So we have to have an P or an R in 1 for sure. Oh, actually, yeah, we can simplify this. Wait a minute. We know that between H and G, right, between these guys, L's taken care of, but between H and G, we still have to have at least 1 person in 1. So that means that, there we go, we would have to have at least 3 courses in semester number 1. The best answer to question number 11 is D. Next, I guess the global, number 7. Which of the following could be a complete and accurate list of courses that they take in 1? So what could be a complete setup? I suppose let's jump in. Answer choice A, could we just have history? And no, I mean, we know that at least 2 placeholders, so that's out of the question. Answer choice B, could we have G and R? And maybe, I mean, take this placeholder and this placeholder, and does anything else break? I'm not sure that anything does. That seems okay. Let's just check the other ones briefly. Can we have just L and M? And no, because we have to have one of P or R, for example, so that's not going to work. Can we have G, M, R? And, I mean, G and R would take, oh no, because M and P have to be together, so you would have to have a P there. That's not going to fly. Answer choice E, G, H, L, R. Can we have G, H, L, and R? Maybe? I mean, M and P would have to go to the other side, but otherwise, I'm not seeing an issue. So I think we're down to answer choices B and E. So could they take just G and R in semester number 1? Now, to be fair, if we put G and R and only G and R, no, that's not going to work, because notice, we still have a relationship between H and L, right? If we put just G and R in number 1, H and L don't play nice on 2, which means that one of them is going to get pushed into 1. And so that would get rid of it. So best answer here is answer choice B for number 7. Next, number 9. Which of the following could be the only course that they take in semester number 2? So what could go into number 2 alone? Ooh, this is fun. Well, I mean, we know that M and P definitely could not ever be alone, so we can get rid of answer choices C and D. So that's a fun start. Actually, wait a minute. We know that one of these guys, we have to have an M, G, or an L. So we can get rid of any answer choice that is not M, G, or L, because if anybody else was going to go into number 2, they would have to go with this, whoever this is, right? So they would never be there alone. So we can get rid of answer choice A, and we can get rid of answer choice E. There we go, because R could not be there alone. So best answer to question number 9 then becomes B.